In the previous video, we have completed our first behavior using FlexB. We defined the user data and behavior variables, and we configured the states in our state machine. So now it's time to see if we have successfully implemented the desired behavior, that is, pick a part from the conveyor belt with Robot1 in our factory. We will execute our FlexB behavior for this. As we mentioned, when we presented FlexB, in addition to support behavior design with the state machines, FlexB allows to execute the behaviors. This is done in the runtime control view. So let's go from the state machine editor to runtime control, and oops, it says no connection. Remember that we said that only opening the FlexB app allows you to edit behaviors, but not to execute them. For this, we are missing the connection to our ROS application. Actually, what we miss are two very important things. First, we are missing our ROS application. Without the ROS core and the nodes that implement our capabilities, we cannot execute any action. Okay, to launch our ROS application for the pick example in the factory, we can simply use ROS launch with the hrwros pick demo launch file that we included in the repository of the course. And second, we need to launch the complete FlexB behavior engine so that we can execute our behavior. So first, we close the FlexB app if we have it open, and then we can launch the FlexB behavior engine in another terminal. For this, we can use the behavior testing launch file in the FlexB onboard package. So let's do this and execute our behavior. Okay, so in a terminal, we launch the Gazebo factory simulation for the pick example. Here it is. And in another terminal, we launch the FlexB behavior engine. Okay. This also brings up the FlexB user interface, but note that now it is online. This is connected to our ROS system that is running. We can now go to the runtime control view. Here we are. We have not loaded any behavior, but we can do it here. Let's select, of course, our pick part for conveyor behavior. And we click Start Execution. Okay, the active state and possible transitions are displayed here. And below, we have feedback about the behavior execution. But let's also see what is happening in our factory simulation. In Gazebo, we can see that Robot1 moves to pick the part and retreats. It worked. Our FlexB behavior successfully coordinated the ROS nodes to execute the actions defined in our state machine to pick a part from the conveyor belt. All right, now you already know how to use FlexB and available state implementations to develop your own robot behaviors and execute them. However, in occasions, this is not enough. What if for our behavior we need some robot capability for which there is no FlexB state available yet? For example, in our factory, the parts will not normally appear magically next to the robot, but the conveyor belt will bring them to it. Actually, the repository for the factory simulation includes a ROS node to control the conveyor belt. All we need is a FlexB state implementation that uses that node so that we can control the conveyor belt in our state machine. In the next unit, we will learn how to create such a state implementation.